Every time you open YouTube, something invisible is watching, and it knows you better than you think. YouTube's recommendation algorithm decides what 70% of all videos you ever watch. That number is not a small detail. It means the majority of your time on the platform is not driven by what you search for or who you subscribe to. It is driven by what a machine decided to show you next. This system processes over 800 million videos. It serves over 2 billion logged in users every single month, and it makes its recommendations in milliseconds. Understanding how it actually works is one of the most important things you can know about the modern internet. Let's start with the failure. In 2012, the metric YouTube optimized for was clicks. If a thumbnail got you to click, the algorithm counted that as success. The video got promoted. More people saw it. More people clicked it. The result was a flood of clickbait. Misleading titles and thumbnails that had nothing to do with the video. Faces frozen and exaggerated expressions of shock or joy. Users were clicking and immediately leaving frustrated and deceived. YouTube was optimizing for the wrong signal. It was measuring intention, not satisfaction. A click tells you that a title was interesting. It tells you nothing about whether the video was worth watching. So YouTube changed what it measured. In 2012, it shifted its core optimization target from clicks to watch time. How long did you actually watch? Did you make it to the end? Did you come back and rewatch a section? This single change transformed the entire platform. Content that delivered on its promises was rewarded. Content that tricked you into clicking but lost you in the first 30 seconds was penalized. The incentive structure for creators shifted overnight, but watch time alone still had problems. A 10-hour ambient music video could accumulate enormous watch time without being genuinely useful. So YouTube added another layer: satisfaction surveys. After watching a video, some users were asked directly, "Are you glad you watched that?" This signal was used to train a model that tried to separate passive consumption from genuine value. Today, the system does not optimize for a single metric. It balances watch time, click-through rate, survey satisfaction scores, rewatches, shares, and dozens of other signals simultaneously. It is a multi-objective optimization problem running at planetary scale. Now let's talk about how the recommendation engine actually works under the hood. The system runs in two distinct stages. The first stage is called candidate generation. The second stage is ranking. Candidate generation exists because the brute force approach is impossible. You cannot score every one of YouTube's 800 million videos for every one of its 2 billion users on every page load. The math does not work. So the first stage does something clever. It narrows the entire video catalog down to a manageable shortlist as quickly as possible. It does this using embeddings. An embedding is a way of representing a complex object: a user, a video, a search query. As a list of numbers, these numbers are called a vector. The vector captures the essential characteristics of that object in a way that a computer can compare and measure. Every user on YouTube has a vector. It is built from your watch history, your search history, your likes and dislikes, the channels you subscribe to, how far through each video you watched, and even what time of day you typically watch. All of this information gets compressed into a single list of hundreds of numbers. Every video has a vector too. It is built from the video's content, its metadata, its title, its tags, how users have historically engaged with it, and dozens of other signals. Both vectors live in the same mathematical space. Candidate generation finds the videos whose vectors are closest to your user vector. This is called nearest neighbor search. In the abstract, it is simple. Find the things most similar to you. In practice, doing this across billions of videos in milliseconds requires approximate methods, purpose-built hardware, and years of engineering. The output of candidate generation is typically a few hundred videos. These are the candidates. They represent the platform's best guess at what you might want to watch before any fine-grained scoring has been done. Then comes ranking. The ranking model takes those few hundred candidates and applies a much more expensive, much more detailed neural network to each one. This network can afford to look at signals that candidate generation had to ignore, because it is only processing a few hundred videos instead of hundreds of millions. The ranking network looks at your complete interaction history with a specific channel. It looks at how recently this video was uploaded, since freshness matters enormously on a platform where news and trends move fast. It looks at the video's click-through rate for users who have a similar viewing profile to yours. It looks at average view duration, not globally, but for users like you specifically. The output of the ranking model is a score for each candidate. The highest scoring candidates become your homepage recommendations and your up next queue. The ranking model is retrained continuously on new data, so its understanding of your taste is always shifting. Now here is where it gets philosophically interesting. If the algorithm only ever recommended more of what you already watched, the system would collapse into a feedback loop. You would watch technology videos, get recommended technology videos, and never see anything else. Your taste would calcify. Eventually you would get bored and leave. YouTube's solution to this is the explore-exploit trade-off. It is a classic problem in reinforcement learning. Exploit means recommending things the system already knows you like. Safe bets that are likely to produce high watch time. Explore means occasionally recommending something outside your established taste profile, taking a small calculated risk. The explore fraction is deliberately injected into your recommendations. Some percentage of what you see on your homepage is a bet the algorithm is placing on something new. A cooking video when you mostly watch engineering. A travel documentary when you mostly watch comedy. The system is probing for undiscovered preferences on your behalf. When an exploration succeeds, when you watch that unexpected video all the way through, two things happen. Your user vector updates to reflect the new interest, and the algorithm reinforces the behavior of exploring in that direction. You have taught the system something new about yourself. When exploration fails, when you immediately close the video, the system notes that too. That direction is penalist. Future explorations will avoid similar territory. This is how YouTube's understanding of your taste evolves over time. It is not static. It is a continuously running experiment with you as both the subject and the signal. Let's talk about cold start. Cold start is the problem of what happens when the algorithm has no data to work from. It applies in two situations: a new user joining the platform and a new video being uploaded. For a new user, the system has no watch history, no interaction history, nothing to build a vector from. The solution is to use broad demographic signals and initial interactions. The first few videos you watch or click on matter enormously. They seed your vector and shape everything that follows. This is why YouTube's new user experience feels aggressively curious. It is trying to gather signal as fast as possible. For a new video, the problem is similar. A video uploaded 5 minutes ago has no watch history and no click-through data. The ranking model cannot score it properly because all its inputs are missing. YouTube's solution for new videos from established channels is a small initial push. The video is shown to a sample of the channel's existing subscriber base, people who already have a demonstrated interest in this creator. Their reactions become the first round of data. If that initial audience watches long and engages positively, the system scales the video up. It gets shown to progressively larger and less familiar audiences. If the initial audience drops off early, the video stays small. This is why the first 24 to 48 hours of a video's life are so critical for creators. Early engagement is the seed that the algorithm uses to decide how far to spread the video. This has reshaped how creators think about their work. The algorithm has become an invisible co-creator. Creators study retention curves, graphs that show second by second what percentage of viewers are still watching. A sharp drop at a specific moment tells a creator that something in the video failed. They re-edit future videos to smooth those drops. The content itself gets shaped by the algorithm's feedback. Creators engineer strong openings. The first 30 seconds of a video are crucial because the algorithm gives extra weight to whether users make it past that threshold. Creators write hooks, create pattern interrupts, tease the payoff of the video early, all to push that retention curve up at the start. End screens and cards are used to drive viewers directly to more videos, extending watch sessions. A viewer who watches 4 of your videos in a row is far more valuable to the algorithm than one who watches 1 and leaves. The metric the algorithm most rewards is session initiation, being the video that starts a long viewing session, not just a single watch video. The result is a system where the algorithm and the creators are locked in a continuous co-evolution. Creators adapt to the algorithm adapts to shifting viewer taste. Neither side controls the other. Both are responding to the other's moves. What you see on your YouTube homepage is the output of all of this. Billions of user vectors, hundreds of millions of video vectors, 2 neural networks running in sequence, an explore-exploit balance, a cold start mechanism, a satisfaction model. All of it retrained, continuously and running in milliseconds. It is one of the most complex personalization systems ever built, and it is invisible to almost everyone who uses it. It is one of the most complex personalization systems ever built, and it is invisible to almost everyone who uses it every day. That is how YouTube knows what you like. Thanks for watching.